Next, I want to get to the city. Oh, we got the great doctor coming in here. Uh-oh, yeah. She's moving us up.
I'm the Raw Squad up. Black African Power family. Black African Power. All praises to the ancestors. All praises to the ancestors. All day long you've been hearing that the black woman is God and they believe in Ma'at. But yet you didn't hear sister get on stage and speak to you today. But I'm getting ready to speak to you. I'm getting ready to speak to you. The black woman is God. She is God. I'm here today to establish that mathematical thought was born in South Africa, and the ancestors brought it up to Central Africa, traveled up to the Nile, through the Nile, where the mathematical ideas culminated in Kemet. So what I'm going to do is present Paleolithic archaeological evidence to support my claim, and I'm going to show you the birth of mathematical thought and show you the evolution of mathematics in South Africa and in Africa. Oh, I'm sorry, East Africa. Let's go. So what you're looking at is the Lebombo bone. This bone is dated to 37,000 years. So it's 37,000 years old, and they found this Lebombo bone in South Africa. You can find the bone in the McGregor Museum of Kimberley in South Africa.
Is that lines though? Is that like...
Let me get to that. So this is the geographical location of the Lebombo bone. So if you look at the map shows that the Lebombo bone was found near the border cave in the Lebombo Mountains. Where? In South Africa. This Lebombo bone is considered the oldest mathematical instrument in the world. So what does this tell you? That mathematics was born in the South. This site was first excavated in the 1930s and 1940s, and the excavations revealed that this cave was occupied for 120,000 years. Okay, 120,000 years. They found several human bone fragments, an infant, 5 hominins, 69,000 artifacts, 43 mammal species. So this is a very, very important archaeological site. Now let's get to the Lebombo bone. Let's go. So the Lebombo bone was considered the most fascinating discovery in the cave. This bone was discovered in 1970s by Peter Beaumont, okay? And initially they considered it to be a tally stick. But I want y'all to pay attention to this. It's the fibula of a bamboo, which consists of 29 notches. So there were 29 notches, 29 markings in the bamboo stick. When you think of 29, you automatically think about the lunar calendar, right? Which is 29.5 days. Well, when you think about the lunar calendar, you can't help but to think about the menstrual cycle, right? So this Lebombo bone shows that the first mathematicians in the world were probably African women. A woman was the first mathematician in the world. Some African woman that probably was tracking her menstrual cycle like the sisters track their menstrual cycles today. Alright? So this makes the African woman the first observer of periodicity. Because we track our cycle, we track our birth cycle. Our body, we are the epitome of a cycle. So the first mathematician in the world was probably a woman. This Lebombo stick probably belonged to a woman who was tracking her cycle.
That's right.
So I want you to go back, Isaiah, 1 second. Now I want y'all to pay attention that these markers were made on the fibula of a bamboo. Okay? Seti talked about a bamboo. You heard Brother Ark talk about a bamboo. So I'm going to show y'all the significance behind the bamboo. Okay? Let's go. What you're looking at right here on this slide is the god, the Necha, Jehudi. You heard of Jehudi? A lot of people heard of Jehudi. Some people call him Thoth. Alright? Now Jehudi was associated with divine articulation, speech, writing, science, and what? Mathematics, right? I just showed you a baboon fibula with markings on it, and the oldest mathematical instrument in the world, and it was written on what? A baboon. Well, look how Jehudi is depicted. Jehudi is depicted as what? A baboon. So this shows you the South African influence in Kemet. Let's go to the next slide. So if you're looking at this slide, this is the land of the soul. You see this picture all in Kemet. Pyramids, temples, they had the land of the soul. Well, look at the top of the scale. What do you see? You see a baboon. you see a baboon. So the baboon was indigenous to the South. Let's go to the next slide. Let's go to the next slide. So the baboon, right? This is a paper that was published in the +1 journal. It is dated to December 2014. And in this paper, the scientists are talking about a 2-million-old baboon skull that they found where? In South Africa. So baboons weren't indigenous to Kemet. The baboons are indigenous to South Africa. And just like the ancestors migrated upward, so did the baboon. So that's why you see a baboon in Kemetic culture. Because the people of the South brought with them the culture. They brought the baboon up north. Let's go. Now what you're looking at is the Ishango bone. This is okay. Now your brother's cheering on. Now what you're looking at is a picture of the Ishango bone. This is the second oldest mathematical instrument in the world. Where did they find this bone? This bone is dated to 20,000 years old, and you can find it in the Royal Belgian Institute of Natural Sciences. 20,000 years, second instrument. Where did they find it? Let's go to the next slide. They found it in the Congo region. Well, wait a minute. We're coming up now, right? Because I just showed you that the oldest mathematical instrument was found in South Africa. Now you see that the second oldest mathematical instrument was found in Central Africa. So that shows that the ancestors brought it up, right? So it was found in northeast, the Ishango bone was found in the northwest Congo region. They called it right in the Virunga National Park. Okay, that's where it was found. Let's go. Oh, I'm sorry. Let's go back. And when they excavated that site, the stratigraphy, right? So when we're talking about stratigraphy, we're talking about the study of the layers. That revealed that this site was between 20,000 and 25,000 years old. And when they found that Ishango bone, they found it in a layer that was dated to 20,000 years. Let's go. So this is the geographical region of the Ishango site. So now we're talking about the Great Lakes region. This is the Great Lakes region, right here on the western branch of the East African Rift System. That's what we're talking about, this area. And when they excavated it in the 1930s and 1950s, they found bones of Homo sapiens. They found harpoons, right, for fishing, and they found quartz tools. But the most fascinating find was what? Let's go. It was the Ishango bone. It was discovered in the 1950s. Again, it was 20,000 years old, and it was a prehistoric composite tool, which means that it was made of two materials, right? It was made of quartz and bone, and it contained 168 parallel marks. Look at the markings, brothers and sisters. It has marks on it. Now, when I was looking at the Ishango bone, I couldn't help but think about in elementary school. You know how they teach you how to count on your fingers? And then if you couldn't count on your fingers, what did they tell you to do? Use markings, right? Use markings. And then when you had a certain number of markings, you crossed it out because that represented a group, right? Well, let's see what the ancients did. Let's go. Jean, the European that found it, this is what he postulated. He said that the groups represented numbers. No duh, we did that in elementary school. He said that the groups probably represented numbers. We know that. He said that I want you to look at the center column. It shows a number and it's double. So if you look at the top, the double, if you double 3, you get 6. If you double 4, you get 8. If you double 5, you get 10. So it followed that pattern until you got to the last 2 numbers. Now if you look at the left column, it showed prime numbers. What is a prime number? A prime number is a number that's divisible by itself or 1. So it showed prime numbers, 11, 13, 17, 19. If you look to the right, he said that it could be linked to a base 10. If you look at 11, 11 minus 1 is what? 10. If you look at 21, 21 minus 1 is 20. 19 plus 1 is 20. 9 plus 1 is 10. So they had an understanding of bases and they linked it to base 10. All right? Other researchers say that it could have been a system notation relating again to what? The lunar calendar. So the Lebombo bone probably belonged to a sister who was tracking her period, and the period correlates with what? The moon, the lunar cycle. Making again the African woman the first mathematician in the world. Let's go. So these are my postulates. I just showed you that the oldest mathematic instruments were found in Central and Southern Africa, and I provided you with archaeology that gives credence that rudimentary mathematics mathematics, prime numbers, things of that nature. So rudimentary mathematical ideas were brought up from the South, right? Where it went through the central region and it culminated in Kemet. So in Kemet, no air brought mathematics to Kemet, no Hebrew brought mathematics to Kemet, no Greek brought mathematics to Kemet. The ancestors from the South brought the mathematics to Kemet, where they took it to another level, all right? And they manifested wondrous structures that were built with mathematical foundations. So I'm gonna give y'all an example. We're gonna get ready to get into the mathematics. Because I don't want to sit up here and just show you archaeology. I like math, because with math you can prove it. It's logical, you can prove it. So let's get into the math. Let's go. So we get ready to get into the math of the Great Pyramid, the Great Pyramid of Khufu, all right? This Great Pyramid was constructed around 2600 BCE. It consists of 2.3 million stones, weighing between 2 and 70 tons, all right? And, and another thing that I want to bring up is that this pyramid, and this is important, this pyramid is aligned to the true north. It's aligned to the true north. The elder, Anthony T. Browder, said that it's off by 1/12 of a degree, but he said this was not because an error on its creators. It probably was an error due to the shift in the earth crust, okay? So this pyramid was aligned to the true north, which means that the ancestors understood geometry, right? And to the north, if you don't understand geometry, if you don't understand angles, you can't do it. All right, so the ancestors had an understanding of geometry. So let's get into the math. Oh, this blew my mind, family. When I looked at this, this blew my mind. Okay, so this is the mathematics behind the Great Pyramid. Now I want to read something to you that's written in Anthony T. Browder's book, Nile Valley Contributions to Civilization. In his book, he says this, point right here. He says, dividing the perimeter of the pyramid's base by twice its height yields 3.1428. which is a working approximation of pi, often used by contemporary engineers in construction. So he made the claim that the Egyptians understood how to calculate pi. But I said, well, wait a minute. I want to prove it. That's not good enough for me. Let me prove it. So this is what I did. I said, this is what I did. I said, well, in order for that to be possible, then the base of the Great Pyramid is a square, right? Pointing to square. The base of the pyramid is a square, right? Whose perimeter is equal to the circumference of a circle. So they build the base. They build the base of the pyramid based on the perimeters of a circle. That's the only way his statement could be true. So this is what I did. I set up the equation. I said P is equal to C, which is equal to 2 pi r. Isn't that the circumference of a circle, 2 pi r? We learned that. We all learned that in middle school and in high school. 2 pi r. But the radius would have to be equal to the height of the base in order for Anthony T. Browder's statement to be true. So I actually went through this and did the mathematics myself to make sure that what he said was right and exact. All right? So P is equal to C. P is equal to C, which is equal to 2 pi r, where r is the height of the pyramid. Well, wait a minute. The height of the pyramid is 481 feet. You guys can Google that. You can wiki that. The height is 481 feet, and the base is 756 feet. When I plugged that in, what did I get? I got 3.1428, which is equal to what? Pi. So I said, wow, Anthony T. Browder was correct. The ancients understood how to calculate pi and built a structure based on pi. I mean, that's amazing. They understood pi. That is amazing. But hold up. I want to note this. According to Sheikh Anti Diop's work, the Babylonians, they miscalculated pi. They calculated pi to be 3. The Greeks calculated, a lot of people give credit to the Greeks and say the Greeks calculated pi to be 3.1428. But I'm showing you a structure that precedes the Greek mathematicians. So I'm showing you that it was us. We calculated pi, but they give all the credit to the Greeks, or they give all the credit to the Babylonian mathematicians. But I just showed you a structure that precedes all of them. I just showed you a structure that precedes the Babylonian dynasty. So this demonstrates that the ancestors understood algebra. They understood geometry. Let's go. So let me keep going. Anthony T. Browder also claimed in his book that the pyramid design was in accordance with phi. And he called phi a golden number. But I just want to correct the elders. It's not a golden number, it's called a golden ratio. Okay? It's actually a ratio. It's the ratio of the hypotenuse to the base. That's what the golden ratio is. And if your design satisfies the golden ratio, then that means that it's an isosceles triangle. So not only did they understand how to calculate pi and build structures based on the calculations of pi, they understood isosceles triangles. But you know what? Again, I don't like to just talk. Let me prove it to you with the mathematics. Let's go. So, no. I didn't say let's go and turn it. I'm saying let's go right here. Okay, so phi is equal to phi is equal to the ratio of the hypotenuse over the base. And this is my statement right here. I said this is true when you use the ratio of the slanted height to 1/2 the base. So y'all saying, Dr. Maya, what the hell are you talking about? I'm getting ready to show you with the picture. Look at the picture. The slanted height is the distance. You see S? It's the distance. You now look at S. Go up and down S. It's S. It's the slant height is the distance measured along the lateral face from the base to the apex along the center of the face. So that's S. All right? So look at R. If you look at R can be calculated as 1/2 times the base, right? So we know the height, right? We know what the height of the pyramid is. We know that it's 481 feet, and we know that the base is 756 feet. So if you plug that in to S equals the square root of H squared plus R squared, you will get 611.755. And then when you take the ratio of the hypotenuse to the radius, look at what you have, family. It's equal to 1.68, which is equal to phi, the golden ratio. So our ancestors understood isosceles triangles. So they understood pi. They understood isosceles triangle. And this also demonstrates that they have an understanding of the triplets. You know, in high school, they hit you with the Pythagorean theorem. I heard it in 9th grade, 10th grade. They say C squared equals A squared plus B squared, right? That's what you hear, the Pythagorean theorem. But if you look at, I think the second or third bullet, you'll see they have S equals the square root. You have S equals the square root of A squared plus R squared. But if I want to get rid of the square root, I square both sides. So then I would have S squared equals H squared plus R squared. So our ancestors understood the triplets of the Pythagorean theorem. Let's go to the next one. But I find it quite appalling that today they still don't give us the credit. I did a quick wiki on the Pythagorean theorem, just a quick wiki to see what they were going to say about it. And you know who they gave all the credit to? The Babylonian mathematicians. They got all the credit, right? I showed you how the Babylonian mathematicians miscalculated pi. So you think the same people that miscalculated pi actually came up with the Pythagorean triplets? It doesn't make sense. So let me read this real fast because I only have a few more slides. There is the debate whether the Pythagorean theorem was discovered once or many times in many places, and the date of the first discovery is uncertain, as is the date of the first proof. According to Johann Friedberg, a historian of mathematics, evidence indicates that the Pythagorean theorem was well known to the mathematicians of the first Babylonian dynasty. But look at the dates, brothers and sisters. It says that the Babylonian dynasty was between the 20th to the 16th century. But wait a minute, I just showed you a structure that was built in 2600 BCE that precedes the Babylonian dynasty, a structure that was built using the Pythagorean triplets. So this is a lie, family. This is a lie. And then they go on to say, another scholar, Bartel Lindert, he says that he conjectured that the Pythagorean triplets were discovered algebraically by who? Again, the Babylonians. The Babylonians. The only thing that they say about Egypt is that the triplets was mentioned in the Egyptian Berlin papyrus, but they say they don't count that. They say they don't count that. They say they don't count that because they didn't specifically apply the problem to triangles. But anybody that's a mathematician,
5 minutes.
All right. But anybody that's a mathematician will understand you don't have to, they didn't. Yeah, I know. Y'all saw that.
Ain't nobody get that 5-minute shit. Now we need some real goddamn information and real knowledge and real wisdom. We need our damn time.
All right. So basically the Babylonian mathematicians were credited with the Pythagorean triplets. These are the same Babylonian mathematicians that miscalculated pi. These were the same Babylonian mathematicians who didn't create a calendar until 310 BC. We had a calendar 4,000, 5,000 years ago. All right, let's go to the next one. Okay, so the mathematical foundation of the structures prove that its creators had knowledge of algebra, geometry, trig, definitely mechanics. Who's picking up a two-ton brick? A 2-ton brick? None of us. So they had to understand how to design ramps to pull it up. So they had to understand mechanics. What is mechanics? Mechanics is a branch of physics that studies the motions. It studies the laws of motion. So they had an understanding of mechanics. They had an understanding of astronomical science. All right? And what did they leave us with? They left us with mathematical papyri that showed and proved that they understood these concepts. You had the Moscow papyri, the Rand papyri, the Berlin 6619, some of the oldest mathematical documents in the world. Let's go next. Next. All right, right there. So what you're looking at right here is the Moscow papyrus, which is found in the Pushkin State Museum of Fine Arts in Moscow. It's dated to the Middle Kingdom, 1850 BC, and it contains 25 problems in geometry. So they knew geometry they were studying geometry back in 1850 BCE. Let's go. Right here, what you're looking at is the Rhind papyrus that's displayed in the British Museum. They think that it was produced by the scribe Amos, and it's dated to the Second Intermediate Period. But this is the most extensive papyri because it contains 84 problems, all right, dealing with the tables of division, multiplication, handling fractions, geometry, and it included volumes and areas. Let's go. I'm almost done, family. I got about 3 more slides. But this is the most important slide right here. Where's the book? Where's the book?
About to make that correction.
We're about to make a correction because the Army Raw Squad, we're not about just regurgitating information. That's easy to do. Read a book and come up here and talk about it. That's not what we do. We read a book, we scrutinize it, we revise it, and we build on it. That's what we do. So let me show you. I read this book. It's called Civilization of Barbarism by Shinkanti Diop. So if you want to understand the mathematics that was practiced by the Egyptian, read chapter 16. It talks about the contributions, Africa's contribution to sciences, and it covers select problems from various mathematical papyri. But I want to bring your attention to this. On page 273, I want to provide you with some clarity. He mentions a problem that he saw in the rhymes, and this is how the problem reads. It reads this. It reads as such: 2/3 plus 1/10 of a number is equal to 10. And then he says, what is it? And then his solution is immediately the equation is written as, and he has in parentheses, 2/3 plus 1/10, both of those quantities multiplied by x is equal to 10. That's wrong. Dead wrong. That's dead wrong. It would be true if it read that the sum of 2/3 plus 1/10 of a number is equal to 10. But if you don't say the sum, then it's wrong. So I just want to correct the elder in saying that you see, if you don't put the sum in there, you just get 2/3 plus 1/10 x equals to 10. So you need to add the sum in order to make it make sense. And again, in the elder's book on page 243 and 266, Shinkanti Diop said that the Egyptians miscalculated pi. He said that the Egyptians calculated pi to be 3.16, but I just showed you that they didn't calculate it to be 3.16. The Egyptians knew that it was you're right, sister, they knew that it was 3.1428. So this elder is what this based on. I think this was published in the 1980s, but now we know better in 2015. Let's go.
All right, let's give it up for Dr. Ma'at.
I did.
Dr. Ma'at, Army Raw Squad.
Army Raw Squad.
Now, family,